Imagine a time when software was like a giant mountain, towering over everything else in the landscape of technology. This mountain was a single, massive entity, a monolith that stood alone, unyielding and formidable. It was difficult to scale, update, or maintain. Developers found themselves constantly struggling, much like climbers on a steep, rugged terrain. This was the era of monolithic applications, where software was built as a single, indivisible unit. Developers faced constant challenges in managing these complex systems. The stress was palpable, and the frustration was real. Every change, however small, required deploying the entire application. This meant long nights and tedious processes. This made updates slow and risky. A single error could bring the entire system to a halt, causing anxiety and delays. Scaling was also a major headache. Handling server loads and scaling the infrastructure was a constant battle. If one part of the application experienced high demand, the entire monolith had to be scaled. This was neither efficient nor practical. This was inefficient and expensive. The costs of maintaining and scaling such systems were exorbitant. The monolithic approach hindered innovation and agility. Teams found it hard to pivot or introduce new features quickly. Developers longed for a better way to build and deploy software. They dreamed of a more flexible, efficient approach. The industry needed a solution to break free from the constraints of monolithic architecture. A new path was essential. Virtualization emerged as a promising path towards greater flexibility and efficiency. It allowed for more dynamic and scalable solutions. This marked the beginning of a new chapter in the story of software development. A chapter filled with hope, innovation, and endless possibilities. Virtualization emerged as a way to break down the monolithic mountain, a towering obstacle in the world of computing. It allowed developers to run multiple virtual machines on a single physical server, transforming how resources were utilized. This brought about significant improvements in efficiency and resource utilization, making data centers more productive and cost-effective. Each virtual machine could run its own operating system and applications, providing flexibility and versatility. This provided isolation and improved security, ensuring that applications could run without interfering with each other. Virtualization offered several benefits over the monolithic approach, including better resource management and scalability. It enabled faster provisioning of resources and improved disaster recovery, allowing for quicker responses to failures. However, virtual machines were still resource-intensive, consuming significant CPU and memory resources. They required a full operating system to run, adding overhead and complexity to server management. The industry needed a more lightweight and portable solution, one that could reduce overhead and simplify deployment. This led to the rise of containers, a technology that promised to address these challenges. Containers promised a more efficient and agile way to develop and deploy applications, streamlining the software development process. They were about to revolutionize software development, offering a new paradigm for building and running applications. This was the dawn of the container frontier, a new era in computing that would reshape the landscape of data centers and software development. Containers emerged as a lightweight alternative to virtual machines, revolutionizing the way we think about application deployment. They allowed developers to package applications and their dependencies into isolated units, ensuring consistency and reliability. These containers could run consistently across different environments, from development to production, without any modifications. This portability was a game changer, enabling seamless transitions and reducing deployment headaches. Developers could now build and test applications on their laptops with ease, knowing that what worked locally would work in production. They could then deploy them to production servers with confidence, minimizing the risk of unexpected issues. Containers offered significant advantages in terms of speed and efficiency, drastically reducing the time needed to start and stop applications. They were much smaller than virtual machines, consuming fewer resources and allowing for higher density on the same hardware. This allowed them to start and stop much faster, making them ideal for dynamic and scalable environments. This speed and efficiency made containers ideal for microservices architecture, where applications are composed of small, independent services. In this approach, applications are broken down into small, independent services, each running in its own container. While containers offered numerous benefits, managing them at scale presented a new set of challenges, requiring sophisticated tools and strategies. This led to the emergence of container orchestration platforms like Kubernetes, which automate the deployment, scaling, and management of containerized applications. As developers embraced containers, they quickly realized the need for effective management. Deploying and scaling containers across multiple servers became increasingly complex. This led to the orchestration crisis. Manually managing large numbers of containers was not feasible. The industry needed a solution to automate container deployment, scaling, and networking. This is where Kubernetes entered the scene. It emerged as a powerful open-source platform for container orchestration. Kubernetes provided the tools and capabilities to manage containerized applications at scale. This marked a turning point in the evolution of software infrastructure. Kubernetes provided a solution to the chaos of the orchestration crisis. It brought order and automation to container management. This enabled developers to focus on building and deploying applications. Kubernetes, often shortened to K8s, emerged as the hero in the story of container orchestration. Developed at Google, Kubernetes leveraged their extensive experience with container management. It quickly gained popularity in the tech industry. Kubernetes provided a robust and scalable platform for deploying, managing, and scaling containerized applications. Its ability to automate key processes such as deployment, scaling, and networking made it an invaluable tool for developers. Kubernetes simplified the complexities of container management. This allowed developers to focus on what they do best: write code. To understand the significance of Kubernetes, it's important to delve into the specifics of container orchestration. Container orchestration is the automation of operational tasks related to containers. This includes deployment, scaling, networking, and container lifecycle management. Kubernetes excels in each of these areas. Deployment. Kubernetes automates the deployment of containerized applications across a cluster of servers. Scaling. Kubernetes can automatically scale applications up or down based on demand. Networking. Kubernetes provides a robust networking layer that enables communication between containers and services. Lifecycle management. Kubernetes manages the entire lifecycle of containers, from creation to termination. Kubernetes' ability to automate these tasks makes it an essential tool for modern software development. The open-source nature of Kubernetes further contributed to its widespread adoption. Kubernetes' success can be largely attributed to its open-source nature. As an open-source project, Kubernetes fostered a large and active community. This community contributed to its development, making it a powerful and versatile platform. The open-source model ensured that Kubernetes remained accessible to developers and organizations of all sizes. This openness and collaboration were key to Kubernetes' rapid rise in popularity. The impact of Kubernetes extended far beyond the tech industry. It led to a widespread transformation across various sectors. Industry transformation. Kubernetes has played a pivotal role in enabling digital transformation across industries. From finance to healthcare, organizations have embraced Kubernetes to modernize their infrastructure. This has led to increased agility, efficiency, and innovation. Financial services. Banks and financial institutions are using Kubernetes to build more resilient and scalable systems. Healthcare providers are leveraging Kubernetes to improve patient care through data analytics and personalized medicine. E-commerce companies are using Kubernetes to handle massive spikes in traffic during peak seasons. Kubernetes has become the de facto standard for deploying and managing cloud-native applications. For developers, Kubernetes has become an essential skill. Kubernetes for developers. Kubernetes has become an indispensable tool for developers. Understanding Kubernetes is crucial for building and deploying modern applications. It provides the foundation for cloud-native development. Developers with Kubernetes skills are in high demand. Learning Kubernetes can open up new career opportunities. The future of cloud-native applications is bright. Kubernetes is at the forefront of this revolution. The future of cloud-native. Kubernetes has paved the way for the future of cloud-native applications. Its ability to seamlessly manage distributed systems makes it ideal for serverless computing, edge computing, and other emerging technologies. As businesses continue to embrace digital transformation, Kubernetes will play an even more critical role in shaping the future of software development. Kubernetes has come a long way since its inception. It has transformed the way we build, deploy, and manage applications. Conclusion: the journey from monolithic applications to the cloud-native world has been marked by significant advancements. Kubernetes stands as a testament to the power of open source and the transformative potential of cloud computing. As we look to the future, Kubernetes will continue to empower developers and organizations to innovate and build the next generation of software applications. The Kubernetes saga is far from over. It's just the beginning of a new era in software development.